Hello once again. Welcome back to the classes. And in today's class, we'll be doing chemical properties of carboxylic acid. Before that, reminder of the last class. In last class, we did some of the chemical properties of aldehydes and ketones. In that, we did aldol condensation and Cannizzaro reaction. In aldol condensation, I told you that it's basically the acidic character of aldehyde and ketone which is responsible for aldol condensation of aldehyde and ketones. And as far the Cannizzaro reaction is concerned, that is the self-oxidation reduction reaction. And we did intermolecular and intramolecular Cannizzaro. After that, we did the method of preparation of carboxylic acid. So today we'll be doing the chemical properties of carboxylic acids. We'll see what are the basic types in which we can divide the chemical properties of carboxylic acid. Well, in that case, I'll show you the molecule of a carboxylic acid. Well, a molecule of a carboxylic acid is somewhat like this. So as far as its chemical properties are concerned, they can be divided into three main types. That is the reactions involving cleavage of oxygen-hydrogen bond, first type reaction. The second type reaction involves the cleavage of carbon-oxygen bond. And the third type reaction involves whole of the acid molecule. So these are the three different reactions which we are going to see here. So first of all, I am starting with the first type reaction, that is involving cleavage of oxygen-hydrogen bond. Reactions involving cleavage of oxygen-hydrogen bond. Well, in these reactions, we have reaction with either an active metal or a salt of it. That is, I can do a reaction with active metal like sodium. So if I react an acid with a sodium, that is RCOOH, if I am reacting this, this is not H, in fact it is OH. So let me correct that. So here I have got a carboxylic acid molecule. Suppose I have got 2 moles of this and I am reacting it with 2 moles of sodium. I will end up with 2 moles of RCOONA along with liberation of hydrogen gas. Similar type of reaction we can also carry out with the sodium bicarbonate. Suppose I have compound like this, RCOOH, and I am reacting it with NaHCO3. On reaction with NaHCO3, I will get compound RCOONA plus CO2 plus H2O. Well, this second reaction is used as a test to detect the presence of carboxylic group. In this, whenever we react a carboxylic acid with sodium bicarbonate, we get effervescence of CO2. So this is the reaction in which we are getting effervescence of CO2, and this reaction is used as a test to detect the presence of carboxylic group. When we talk about the first one, the first reaction, well, this reaction I'm talking about, this reaction is very important here. What we are doing reactions involving cleavage of oxygen-hydrogen bond. And you can see that Na positive is substituting H positive. The compounds which reacts with metals to give hydrogen gas, they are acids. That means we are seeing the acidic character of carboxylic acids. So we'll talk about that, the acidic character of carboxylic acids. Acidic character of carboxylic acids. Well, let us have a look at a molecule of carboxylic acid and see why it behaves like an acid. The molecule is like this. In this molecule, the oxygen which is attached to the carbonyl carbon will withdraw pi electron toward itself. So it will become negative, will induce a positive charge on the carbon. So this carbon can get electron either from this alkyl group or from this OH group. Well, OH group has got a higher electron donation as compared to alkyl group because here oxygen withdraws electrons from hydrogen. It releases hydrogen as H positive ion. and itself it will become RCOO negative carboxylate ion. And this carboxylate ion is stable due to resonance. So we have resonating structure of this carboxylate ion like this. This double bond will keep on moving. So as compared to carboxylic acid, the carboxylate ion is more stable due to resonance. So carboxylic acids have a prominent tendency of donating H positive ion and getting converted to more stabilized carboxylate ion. So this is how carboxylic acid they exhibit their acidic character. Once again, the oxygen in carbonyl group is electron withdrawing. It will withdraw pi electron toward itself. It will become negative. It will induce positive charge on the carbon atom. That carbon atom will withdraw electron from the OH group. The oxygen in OH group will withdraw electron from hydrogen, will donate hydrogen as H positive ion. So it will donate H positive ion, it will behave like an acid. Here I would like to add one more thing. And this question is quite an important one. Kindly pay attention toward this one. Here if you see what we have already done. We just before this chapter, just before carboxylic acid, we finished up aldehydes and ketones. Let us have a look at a aldehyde or a ketone molecule. Its general structure is like this. Here also you have got a carbonyl group. What was happening there in aldehyde and ketones, the pi electrons were moving toward oxygen, oxygen was becoming negative and carbon was acquiring a positive charge. So it was easier for a nucleophile to attack on this carbon atom, and that's why the basic property or a very common chemical property of aldehyde and ketones was nucleophilic addition. We did two different type of nucleophilic additions, that is nucleophilic additions and nucleophilic additions followed by elimination of water molecule. So nucleophilic addition is a quite common reaction of aldehydes and ketones. Now the question comes to our mind, similar type of carbonyl group is present in carboxylic acids. Why these carboxylic acid does not undergo nucleophilic addition reaction? We have got a carbonyl group here. Again the same thing can happen. The pi electron, see here, the pi electrons are withdrawn by the oxygen atom. So we are getting positive charge on the carbon atom. We are getting a carbocation. Why it is not that nucleophile will attack on this carbocation and it will undergo nucleophilic addition reaction? Well, the answer is here. You can see these two resonating structures. The answer lies in this. Here, due to resonance, the positive charge on carbocation is very less. It is very weak. As soon the carbon will acquire a positive charge, another oxygen will donate its electron to carbon. So pi electron will keep on moving from one carbon atom to another. That means the positive charge on carbocation will be weaker. It is so weaker that even a nucleophile, it becomes difficult for a nucleophile to attack on this. And that's why, in spite of having carbonyl group, carboxylic acid does not undergo nucleophilic addition reaction like aldehydes and ketones. Here we will compare acidic character of some of the acids. Well, a very common question comes to our mind. Which among aliphatic and aromatic carboxylic acid is more acidic and why? Now suppose I have an aliphatic carboxylic acid, that is RCOOH. As soon the pi electron will come toward oxygen, oxygen will become negative, carbon will acquire a positive charge. Now when the positive charge will come on carbon, you have two different groups there which are ready to donate their electrons to this carbocation. One is the alkyl group and another one is the OH group. Well, alkyl group has got a plus I effect. They are ready to donate their electrons quickly. So here you observe a plus I effect from alkyl group. Higher the plus I effect, more will be the electron donation from alkyl to the carbocation. So weaker will be the positive charge on the carbocation. When you will have weaker positive charge on the carbocation, it will withdraw less electron from the OH group, leading to the donation of lesser number of H positive ion. That means aliphatic acids are weaker acids. So now let us have a look at aromatic acid. Suppose I have got C6, H5, C double bond O, OH. Here in this case, I've got benzoic acid. Same thing happens here also. The pi electron will come toward oxygen, that will become negative, carbon will acquire a positive charge. Benzene again has got plus I effect. But the plus I effect of benzene in this case is lesser as compared to alkyl group. The alkyl group has got a stronger plus I effect as compared to benzene or aryl group. Now, when the electron donation is lesser from benzene, that means the positive charge on carbocation is stronger. It will withdraw electron from OH negative ion, OH group, leading to the donation of more number of H positive ion. So carbocation will withdraw electron from OH group. It will lead to the donation of more number of more number of H positive ion, and that's why aromatic carboxylic acids are more acidic than aliphatic. One thing you have to keep in mind, that no matter whether it is alkyl group or an aryl group, if they are attached to a carboxylic group is electron withdrawing, it will withdraw electron from both of these groups. No doubt, the electron donation of alkyl group is more as compared to aryl group. So aromatic acids are more acidic than aliphatic acids. But there is one aliphatic acid which is even stronger than aromatic acid, and that acid is formic acid. If I talk about formic acid, there is no electron donation of hydrogen. So hydrogen does not donate any electron, neither like alkyl group nor like aryl group. It has got, or we can say it has got a electron donation still lesser than an aryl group. So since there is no electron donation, pi electron will come toward oxygen, carbocation will be formed, that will withdraw electron from OH, leading to the donation of H positive ion. So formic acid is a stronger acid, even as compared to aromatic acids. So this is a basic trend. Formic acid is the strongest one, then comes aromatic acids, and in the last comes aliphatic acids. Well, what are the factors on which the acidic character of carboxylic acids depends? Well, the acidic character of carboxylic acids depends on the two factors which we have already done in alcohols. They are the first one, plus I effect. This we have seen here. The higher the plus I effect, the lesser will be the acidic character. So it is inversely proportional to acidic character. It is inversely proportional to acidic character. Second factor is the stability of carboxylate ion. Well, in this case, I'll tell you that greater the stability of the carboxylate ion, the more will be the tendency of the carboxylic acid to donate H positive ion and getting converted to the more stabilized carboxylate ion. And that's why the more will be the acidic character of the carboxylic acid. So this what you have to keep in mind. The more the prominence of the resonance in the carboxylate ion, the more prominent resonance it has got, the more will be the stability. The higher the stability of the carboxylate ion, the more will be the acidic character of that particular carboxylic acid. So these are the two factors which basically governs the acidic character of a carboxylic acid. Here we'll see effect of substituents on the acidic character. Effect of substituents on the acidic character of carboxylic acids. I'm writing the point before explaining, because we have done this point earlier also in alcohol and phenol. Electron withdrawing groups will increase the acidic character, and electron donating groups will reduce the acidic character. Now suppose I've got acetic acid. As compared to acetic acid, chloroacetic acid is more acidic, because chlorine is electron withdrawing. It will withdraw electron, it will reduce the plus I effect of the alkyl group, and acidic character will increase. Dichloroacetic acid is still more acidic than chloroacetic acid, and likewise CCl3 COOH is more acidic. So more the number of electron withdrawing groups attached to the carboxylic acid, the lesser will be the plus effect and higher will be the acidic character. Likewise, if we talk about electron donating group, suppose I have got acetic acid, I can say acetic acid is a stronger acid as compared to 2-hydroxy ethanoic acid or alpha hydroxy acetic acid, because OH group is electron donating. Electron donating group will donate electron, will reduce the acidic character of the carboxylic acid. In aromatic acids also we can say like tolic acid, paratolic acid. Paratolic acid is less acidic than benzoic acid. And benzoic acid is less acidic than para-nitrobenzoic acid. So para-nitrobenzoic acid is a stronger acid because nitro group is electron withdrawing. My dear student, here I would like to tell you one thing, that it is not only the type of substituent group that affects the acidic character, it is also its position which affects the acidic character. The closer the proximity of the group to the carboxylic group, the higher will be the acidic character, or the more will be the influence. Suppose it is electron withdrawing, then in that case the higher will be the acidic character, and if it is electron donating, the lesser will be the acidic character. So it basically depends on the type of substituent group. I'll explain you that by an example. Suppose I have got a compound like CH2F, CH2FCO, or I'll change this example to explain it better. Will not take this example. Suppose I'm talking about a compound like this, butanoic acid. As compared to butanoic acid, this compound, that is 4-fluorobutanoic acid, is more acidic. As compared to that, 3-fluorobutanoic acid is more acidic. And as compared to that, 2-fluorobutanoic acid is more acidic. So what you can conclude from here, that the closer the proximity of the group to the carboxylic group, the more will be its minus I effect, more prominence will be of its minus I effect, and higher will be the acidic character. Likewise, if I talk about an electron donating group, in that case I can say that butanoic acid is more acidic than 4-hydroxy butanoic acid. That is more acidic than 3-hydroxy butanoic acid. And that is more acidic as compared to 2-hydroxy butanoic acid. In this case, a bit rectification. OH group, my dear students, I'm writing the compound. After that, we'll do a sort of a brain exercise to rectify it. Well, you can see butanoic acid. What I am doing, I'm attaching an electron donating group to it, and that is OH group. And you know, I've already taught you this thing, that electron donating group will exhibit plus I effect and they will reduce the acidic character. That means 4-hydroxybutanoic acid is less acidic than simple butanoic acid. Now, what about 3-hydroxybutanoic acid? It is less acidic than 4-hydroxybutanoic acid. What about 2-hydroxybutanoic acid? That again is less acidic than 3-hydroxybutanoic acid. So, as you can see here, the more the OH group is coming closer to the carboxylic group, the more the electron donating or withdrawing group coming closer to the carboxylic group, the more prominent will be its effect, and thus it will influence the acidic character to a larger extent. Same thing we can see for aromatic acid also. I'll take an example of benzoic acid and we'll see through benzoic acid. Suppose I have benzoic acid, and to this benzoic acid I am adding an electron withdrawing group. This is a benzoic acid. I am adding an electron withdrawing group but to the meta position. We know that we have already done this thing in alcohol and phenol, where we were talking about the acidic character of phenols. There, I have taught you this thing, that the effect of the substituent group is more prominent at meta position as compared to at ortho and para position. So, meta nitro benzoic acid is more acidic than benzoic acid. But the effect of this nitro group is more prominent at ortho and para position as compared to meta. So among all nitrobenzoic acids, meta-nitrobenzoic acid is least acidic. After this, we'll have para-nitrobenzoic acid. So here in this case, I've got para-nitrobenzoic acid. And ortho-nitrobenzoic acid will be most acidic. Here I have ortho-nitrobenzoic acid because nitro group is in close proximity with the carboxylic group. It's quite close to that. So minus I effect induced by nitro group will influence the carboxylic group to a larger extent. So the acidic character will increase to a larger extent. After this, I'll show you an electron donating group. This was an electron withdrawing group. See, what we have done by now, we have seen the acidic character of why carboxylic acid, they behave like carboxylic acid, why they have a tendency of donating H positive ion. What are the factors on which their acidic character basically depends? That is plus I effect and stability of carboxylate ion. After that, we talked about the effect of substituent group. Electron withdrawing group will increase the acidic character and electron donating group will reduce the acidic character. Now, at what position will the effect will be more prominent? I taught you that closer the proximity of electron withdrawing or donating group to the carboxylic group, the more will be the influence. And this is what we have done in benzoic acid also. Now, I am giving you an example of an electron donating group. In this, I am taking a simple benzoic acid and attaching an electron donating group to it, that is CH3. As I told you that the effect of the substituent group is more pronounced at ortho and para position and less at meta. So as compared to benzoic acid, metatolic acid will be less acidic. This is metatolic acid. As compared to this, paratolic acid will be less acidic. So at para position CH3, paratolic acid. This is orthotolic acid and here you have paratolic acid. What about, this is metatolic acid. Metatolic acid. Metatolic acid is less acidic as compared to benzoic acid, and paratolic acid is still less acidic as compared to metatolic acid. What about orthotolic acid? Well, orthotolic acid is more acidic than simple benzoic acid. Now the question comes to our mind, CH3 group is electron donating and electron donating group reduces the acidic character. How come it is that CH3 group when it has to ortho position increases the acidic character? Well, this effect is known as ortho effect, and it is observed only in benzoic acid, not in phenol. We cannot take the same analogy to phenols also, and will predict the acidic character in that way. It is only in the carboxylic acids. So this is known as ortho effect. So according to ortho effect, no matter whether it is electron donating or electron withdrawing group, if it is attached at ortho position, it is definitely going to increase the acidic character. And the reason is prominent steric repulsion between the carboxylic group and the group which is attached at ortho position. So this is all about the acidic character and the effect of substituent on the acidic character. My dear student, here I would like to add one more thing. The concept which I am going to teach you right now is probably the last question of this chapter in your textbook. We'll see which among phenoxide and carboxylate ion is more stable and why. If I talk about phenoxide ion, we have done this in phenols, alcohols and phenols. The phenoxide ion is like this. It will donate its electron to the benzene ring. So I will get its structure somewhat like this. Here negative charge. Then this negative charge will move to the meta position. From there it will come to the para position. The next structure I will get like this, where the negative charge is at para position. Then it will move to the ortho position. And in this resonating structure, you will have negative charge at the ortho position. Well, what I want to tell you that if you have a look at phenoxide ion, you have got good 3 resonating structures of phenoxide ion. Whereas if I talk about carboxylate ion, the 2 resonating structures which I have already shown you of a carboxylate ion are like this. So in carboxylate ion, we have only 2 resonating structures. Whereas in phenoxide ion, we can include this one also. We can say that we have 4 resonating structures. And what we have done when we studied about resonance, we studied that the more the number of resonating structures, the higher will be the stability of the resonating structure. Now here in this case, in phenoxide, we have got 4 resonating structures. But still the carboxylate ion is found to be more stable, although it has got lesser number of resonating structures. Please pay attention to this thing, that phenoxide ion has got more number of resonating structures as compared to carboxylate ion. Yet carboxylate ion is more stable than phenoxide ion. Now the question comes to our mind, why? Well, the stability of resonance structure not only depends on the number of resonating structures, it also depends on the atom on which you have got a negative charge or any charge, positive charge, we can say that also. In phenoxide ion, you can see that the negative charge, here you can see, here you can see, here you can see, the negative charge is on less electronegative carbon atom. It is not on more electronegative oxygen. Whereas in carboxylate ion, here you can see the negative charge is on more electronegative oxygen atom, and that's why it is more stable. The negative charge is always more stable on more electronegative element. That means once oxygen will get electron, it will not donate those electrons easily. So it will not undergo any chemical reaction easily, and that's why it is stable. Whereas if carbon, which is less electronegative, has got negative charge, it is susceptible to donate these electrons. An electrophile can attack on it, an electrophile can get electron from it. So phenoxide ion is not that much stable as carboxylate ion is, in spite of having lesser number of resonating structures. So this is all about their first type of reactions, that is reactions involving cleavage of oxygen-hydrogen bond. Now we'll talk about their second type of reactions. The second type of reactions are reactions involving cleavage of carbon-oxygen bond. Cleavage of carbon-oxygen bond. Well, as far these reactions are concerned, in this we basically do the preparation of acid derivatives. Now suppose I react a carboxylic acid with SOCl2, I will get RCOCl plus SO2 plus HCl. Or if I react RCOH with NH3 and heat it, I will get RCO NH2, that is acetamide. If I react RCOH with an alcohol, I will get RCOO R dash, that is an ester along with water. Likewise, if I heat 2 moles of carboxylic acid in the presence of a dehydrating agent like P2O5, if I heat it, I will end up with a compound like this, that is an anhydride. So in all these reactions, you will see there's a breaking of carbon-oxygen bond. So when we talk about the second type of reactions, they basically include the preparation or the formation of acid derivatives. Now we'll move on to the third type of reaction, and with that carboxylic acid will get over. The third type of reaction is reactions involving whole of acid molecule. Reactions involving whole of acid molecules. When I talk about these reactions, they basically include decarboxylation. That means removal of carboxylic group. We have already done these reactions. I'll give you one example like decarboxylation of sodium salt. This you have done in your 11th standard in the preparation of alkanes. Now suppose you have RCOONA and you reacted with NaOH. You heat it with NaOH in the presence of lime. What will happen? Na2CO3 will come out. So Na2CO3 will come out and you will end up with RH, that is an alkane. So alkane is what you will get. Likewise, if you have got silvers, here what I am doing, decarboxylation of silver salt of carboxylic acid. Silver salt of carboxylic acid, if I talk about that, we have already done this in the preparation of halogen derivatives. So again I have got a compound like RCOOAG. I am reacting it with Br2 in the presence of carbon tetrachloride and heat. Carbon tetrachloride in this case is simply a solvent. I will end up with RBr plus AgBr plus CO2. So these are the decarboxylation reactions. Some of the decarboxylation reactions you have already done in the preparation of aldehyde and ketones. Decarboxylation of calcium salt of carboxylic acid. So with this, carboxylic acid is over. In fact, with this, function group 2 is over. We have done aldehyde and ketone and carboxylic acids. So this is what you have to pay attention towards, and you have to do some exercise questions. And in case you have got any doubt anywhere, NCERT question, all intakes example back question. You got any doubt anywhere, just simply click a picture of that and WhatsApp it to me. You got my number on the screen. Any doubt you want to ask, you can ask me anytime. Send that question to me. If I am in a class or I'm busy somewhere, if I could not answer that very moment, definitely you'll get answer after some time. And my request to all of you is please do subscribe my channel to get all the notifications on time, so that whenever I am uploading any of my video, you'll get notification of that. That's all for today. Thank you very much. Thanks a lot.